Hey guys, this is Miss Sarah back with my next lesson. So I have 8-2. It's a derivative of log function still. I would say it's a kind of continuation of our last lesson. So I have a few more examples on finding derivative of log function. But here's the difference. The difference is what you see in the original function, it's not a log function. This is just normal function. Means this can be done by using normal derivative rules. Like you can do normal product rule and you can still do this. But I can actually make this equation into log function and I can apply log properties and I can take the derivative at the end, which would be way easier than normal product rule. How? So let's look at that. So in order to make this function into log function, so let's apply log to both sides of this equation. To both sides of this equation. So if I apply log to both sides, my new equation after applying log would look something like this. Now the reason I did this because once I apply log, then I can just condense the function and I can just take the derivative like normal log function. Okay, now let's expand it first. So log y would stay the same. This one, let's expand it. This one would be 1/2. And then there would be log log of x squared plus 1. All right. Now let's take the derivative. So log y. Let's take the derivative. So you know it's log of y function. It means it would be 1 over y. Since it's y term, so there would be dy over dx. Log of x. Its derivative would be 1 over x. Derivative of this, 1/2 stays the same. Sorry. 1 over x squared plus 1 and derivative is 2x. So this is what I have after taking the derivative. Now rest is just simplifying. So this one I have 1 over x. This one I can cancel out the 2's. So I have x over x squared plus 1. And I have 1 over y dy over dx on this side. Finally, almost there. So I need to solve this equation for dy over dx means I would multiply both sides by y. So this becomes dy over dx. Y, this one, oh, you can combine if you want it. So I can take the LCD. So this becomes x squared plus 1. This one I would multiply by, x squared plus 1. For this equation, I would multiply by another x, which makes it x squared. Almost there. Dy over dx. And now this is where we plug in the original equation. So y is equal to, here's my original equation. So I'll bring back this expression and replace this y with that. So I have x. How about if I say x squared plus 1 into 1/2? And this whole expression, let's combine. It's 2x to the second plus 1 over x squared plus 1. Almost there. Now let's just simplify the whole thing. Okay, I can cancel out the x's, so this x is going to get canceled out. This is x squared plus 1 to 1/2, and this is 1 whole. So let's just cancel out half of that, and now there is 1/2 left. Now finally, my answer would be 2x to the second plus 1 over x squared plus 1 to 1/2, or radical. Here you go. So that's my first example. So what I did, originally it wasn't log function. I applied log to both sides. Once I did it, I just take the normal derivative and then I just did normal process after that. And don't forget at the end, you just have to multiply by y, which is the original equation. So let me show you one more example on this and that's all for today. So let's look at one more like this. I have y is equal to x minus 2 squared. I have square root of x squared plus 1, which is example number 7 on page number 524. Okay, so first I would apply log to both sides. This becomes log y. How about if I skip this step of expanding? I'm just going to do that expanding right away. So this would be 2 log of x minus 1. Guys with me? Because what I did, I'm trying to do two steps in one. So I'm trying to expand and apply log at the same time. So this is, I brought this 2 over, now it's minus, so this is square root, so it means it would be 1/2, and log of x squared plus 1. Again, if you don't understand, you can pause this video and go back. So what I did expanding and applying log at the same time. Now let's take the derivative. This is 1 over y, dy over dx. Let's take the log, or I'm sorry, the derivative. It's 1 over x minus 2. Derivative of the expression is 1. Excuse me, sorry. 1 over 2. Derivative is this, and derivative of the inside is 2x. Now rest is just combining everything. This one, dy over dx would stay the same, and you just have to multiply by y both sides. I'll do it in the next step. This, if I put it together, look, this looks like something like 2 is going to get canceled out. Here you go. Now, next step, I need to multiply by y. So, which is my original equation. So again, I'll try skipping that step. So I'm just going to write down the original equation right away. So my original is, how about if I say x squared plus 1 to 1/2 instead? Now this one, I would combine these two fractions. If I combine fractions by taking LCD, it would be x minus 2, x squared plus 1. This I would multiply by this, and this becomes 2x to the second plus 2. This, don't forget it. Once you multiply x by x minus 2, don't forget to distribute the negative. This becomes negative x to the second and plus 2x. Almost there. Last step is just simplifying and canceling stuff. So I would have x minus 2 squared, x squared plus 1 to 1/2. This, I can simplify. This becomes x to the second, 2x plus 2 over x squared plus 1. Let's try canceling. So this, one of these is going to get canceled out with this. And finally, let's put it together. So I have x squared plus 2x plus 2 over, okay, I have 1/2 of this here, and then 1 whole in the second fraction here. So total, if I combine these, it becomes x squared plus 1 to 3/2. There you go. So that's my final answer. So this is pretty much all for the day. Thank you for watching, guys, and bye-bye.